The planet we're talking about tonight is TRAPPIST-1e. It's a rocky, close to Earth-sized exoplanet orbiting within the habitable zone around the other dwarf star TRAPPIST-1, located 40.7 light years, 239 trillion miles away from Earth in the constellation of Aquarius. Travelers use the transit method to find the planet, a method that measures the dimming of a star when a planet crosses in front of it. The exoplanet was one of the 7 discovered during the star orbiting the star using the observations from Spencer Space Telescope. 3 of the 7 are in the habitable zone. 1e is similar to Earth: mass, radius, density, gravity, temperature, and star flux. It is also confirmed that 1e lacks a cloud-free, hydrogen-dominated atmosphere, meaning it is more likely to have a compact atmosphere like the terrestrial planets in the solar system. In November 2018, researchers determined that of the 7 exoplanets in the multiplanetary system, TRAPPIST-1e has the best chance of being an Earth-like ocean planet, and the one most likely further study regarding habitability. According to the Habitable Exoplanets Catalog, 1e is among the best potentially habitable exoplanets discovered. The most recent observations in 2025 was unable to conclude with confidence if there was an atmosphere or not. It could rule out certain atmosphere scenarios. 1e was detected with the transit method, where the planet blocked a small percentage of its host star light when passing between it and Earth. This allowed scientists to accurately determine the planet's radius at 0.92 Earth's radius with a small uncertainty of about 83 kilometers. The transit timing variations and advanced computer simulations helped constrain the planet's mass, which turned out to be 0.692 Earth's mass, or about 50% less massive than Venus. Only has 82% the surface gravity of Earth, the third lowest in the system, and its radius and mass are also the third least among TRAPPIST-1 planets. With both the radius and mass of TRAPPIST-1e determined with low error margins, scientists could accurately calculate the planet's density, surface gravity, and composition. And initial density estimates in 2018 suggested it had a density of 5.64 grams per centimeter, about 1.025 times Earth's density of 5.51. 1e appears to be unused in its system, as it was the only planet with a density consistent with a pure rock iron composition, and the only one with a higher density than Earth. 1c also appears to be entirely rock, but with a lower density than 1e. But the higher density of 1e applies an Earth-like composition and saw a rocky surface. This also appears to be unused among TRAPPIST-1 planets, as most thought to have density consistent with being completely covered in either a thick, steam hot CO2 atmosphere, a global liquid ocean, or an ice shell. However, refined um, estimates show that all planets in the system have similar densities consistent with rocky composition, with TRAPPIST-1e having a somewhat lower but still Earth-like bulk density. The planet has a calculated equilibrium temperature of 246.1 K, or minus 16.7 Fahrenheit, giving an interval of 0, also known as its black body temperature, for a more realistic planet like Alberta. However, this provides an unrealistic picture of the surface temperature of the planet. Earth's equilibrium temperature is 255 K. It is Earth's greenhouse gases that raise its surface temperature to be to the level of least spirit. If TRAPPIST-1e has a thick atmosphere, its surface could be much warmer than its equilibrium temperature. The planet orbits an M-type optical dwarf star named TRAPPIST-1. It has a mass of 0.089 solar masses, and radius of 0.121 solar masses, and is 2,516 K, 7.6 billion years old. This planet orbits very close to its star, 6.099 Earth's day to 146 hours to complete its orbit. Wow. Despite its close proximity to its star, TRAPPIST-1e gets only about 60% of the starlight that Earth gets from the sun. As for no clear answer found by the James Webb Telescope. Um, the black planet is not to be orbiting within the habitable zone of its parent star, the region where um, crack conditions after properties liquid water may exist on the surface of the planet. 1e has a range of around 0.91 Earth radius, so it is likely a rocky planet. Its host is a optical dwarf is only about 8% of its mass of the sun. As a result, stars like TRAPPIST-1 have the potential to remain stable for up to 12 trillion years. Damn, it is over 2,000 times longer than the sun. This ability to live for much longer is likely one you TRAPPIST-1 will be one of the last remaining stars in the universe. Yeah, here's a picture of it. This is, I mean, literally, I mean, it's possible. 2004 study, according to a 2004 study based on model TRAPPIST-1e could be having its atmosphere stripped by its star possibly as a result of the short orbital period, which would make it habitable to life. The same phenomenon could impact the atmosphere of the other planets of this system. A 2025 study based on 4 observations of TRAPPIST-1e using the James Webb Telescope instrument, researchers were unable to find conclusive evidence for or against the presence of an atmosphere. I would show 2 models the data could equally explain. The first is a flatline model, which could mean 2 things. TRAPPIST-1e is a barrel walk, or it has an atmosphere of an unknown type, completely hidden by a high, thick cloud deck. The second model is a range of nitrogen-rich atmospheres with nitrogen as the dominant gas with the nitrogen snow. There is a curative preference for a trace amount of methane mixed in. The authors conclude that the primary limitation in studying 1e is regulating effective electric star. To overcome this, a new program of 15 additional James Webb Telescope observations underway. This program will observe back-to-back traces of 1e and its neighboring planet, TRAPPIST-1b, which is believed to be a barrel walk. By using signal from the barrel walk planet to correct for the star's activity, it may be possible to reveal whether 1e has an atmosphere. Yep, it's found by Mitchell Gullen, um, La Solar Observatory in Atacama Desert, Chile. Yeah, here's a picture of the solar system. Here's E. It is very disappointing, but that's the way it is. There's another belief system of it. I doubt it, but one can hope and pray. But that's our discussion of 1E.